All right, I'm going to show you how to expand binomials. What you see here is a binomial. A plus b is two terms and it's being raised to the second power. And I'd like to first remind you that you cannot distribute an exponent. So a plus b to the second power is not equal to this. The a plus b squared would have to be rewritten two times down below, as you see, a plus b times a plus b. And you're going to have to distribute the first term to everything in the second parenthesis. And then you're going to have to take the second term and distribute that through to everything in the second parenthesis. And that's what you see in the two red arrows. Your pre-algebra teacher probably called it the FOIL method, but the first two terms, a times a, is a squared. The outer terms, a times b, is ab. The inner terms, which is b times a, but I'm going to write it in alphabetical order just to give me ab. And the last terms here, b times b, gives us b squared. So FOIL, first, outer, inner, last. And I'd like you to notice that the two middle terms here, the O and the I in FOIL, we have one AB and one AB for a grand total of two AB. And we end up with this trinomial here. Now I'm going to put this in a box here, and I'm going to be using this box here a couple times throughout the video, okay? So remember, let's just call it the box, all right? Now the next thing here, we have a plus b to the third power. Now a plus b to the third power, if I expand it, I have a plus b times a plus b squared. So in the previous slide, I expanded a plus b squared as these pieces. Okay, that's what I put in the box there. Now if I carry down the a plus b here, and now I'm going to have to distribute the a here, 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 to give me a cubed, 2a squared b, because this is a 1 and a 1, to give me the 2 here, and a b squared, which is those terms there. Now I'm going to have to distribute the b to everything. Okay, now be patient with me. This has a very happy ending, but I need to show you the pattern and show you how this all works out. So now if I take the b and I distribute the b to those three pieces, b times a squared gives me a squared b. And then the second thing here, b times a b gives me, a b squared. And then the very last term gives me b cubed. Now when I start to combine like terms here, let me get a different color. Let's choose that guy there. Now this is a 2ab, or 2a squared b, and an a squared b. So I have a grand total of 3a squared b. I'm going to bring down the a cubed here. And I have a 1ab squared and a 2ab squared for a grand total of 3ab squared. And then I have my leftover b cubed. All right, so let's go to the next slide here. A plus b to the fourth. Now in the very first slide, I expanded a plus b to the second power. So now I have two of those guys, and I'm going to rewrite it like that and like that. So hold on tight. Here we go. That times that, a to the fourth. This times this. Now it's getting quite messy here. 2a squared b squared. And this times this gives us 2ab cubed. Okay, now I have one more guy here. Now I have to take this and distribute everything through. Here, here, here. I have to do a total of 9 multiplications. I've just done 6 of them. Now I have to take the b here, the b squared, and distribute that all the way through. So I'm going to choose purple. So when I take the b squared and multiply it through, I get a squared, b squared. I get a 2ab cubed, and then a b squared times b squared is b to the 4th. All right, now I'm ready to combine like terms here. So first of all, I have an a to the 4th. Let me bring that down. A to the 4th. Now let's look at a to the 3rd power. I have an a to the 3rd power there and a to the 3rd power there for a grand total of 4a cubed b. Now let's look at the a squared pieces. A squared, a squared, a squared. 1 plus 2 is a grand total of I realized I made a little boo-boo here, and I don't want to do this video all over again. But when I did 2ab times 2ab here, 2 times 2 is a 4. All right, will you guys forgive me? All right, so that's a 4. So now when I combine like terms, I have 1 plus 4 plus 1 for a grand total of 6. A squared b squared. Now I'm ready to combine the terms that only have a to the 1st power. So that's 4a to the 1st, b cubed, and then I have my leftover b to the 4th. All right, now the whole point of this video is to point out to you that whenever you're expanding binomials here to any power, the final answer, 1, 4, 6, 4, 1, happens to be that row in Pascal's triangle. Okay? You'll notice that 1, 3, 3, 1, 1, 3, 3, 1 was the previous one, and 1, 2, 1, 1, 2, 1. So in other words, every expansion of a binomial, the final coefficients, the final answer here will always have the coefficients found in Pascal's triangle, okay? So I went through all of this nonsense to show you that yes, there is a shortcut, and you're going to use Pascal's triangle. So how is binomials related to Pascal's triangle? The final answer when you combine like terms are the coefficients in the triangle. Now before I move on, I need you to understand that, or see the pattern, that this is a to the 4th, 3rd, 2, 1, and notice there's no a here. There technically is an a to the 0 power here, okay? Now a to the 0 power is 1. We don't have to write that, but it fits the pattern. 4, 3, 2, 1, 0. And b, same thing with b. b, there's no b written here, but it's technically b to the 0. 0, 1, 2, 3, 4. In other words, as the powers of a go down, the powers of b go up. So remember that. The powers of a descend and the powers of b ascend. And notice that our final answer here has 5 pieces. 1, 2, 3, 4, 5. And our original exponent is a 4. So you're always going to have one more term than the degree. So, a plus b to the 5th. Am I going to expand this by hand and FOIL all that out? No, you're not. Hopefully you've made the connection that the final answer will be stealing these coefficients here. So I'm just going to simply write 1, 5, 10, 10, 5, 1. Those are the coefficients. A5, A4, and as the powers of B go down, the powers of B go up. Forgot our B here. B to the third plus, okay, degree 5, we have 1, 2, 3, 4, 5, 6 terms. I also want you to notice is that the exponents will always add to get 5 in this case. They add to get 5. So that's a real quick check when you're doing these problems, is make sure you count up the terms and make sure you look at the exponents here, that they always add up to the original. Now that you've seen the pattern with Pascal's triangle, I'm going to show you a problem where you no longer have an A and a B here, all right? And this is, I would say this is where it starts to get a little bit more difficult. So I just showed you A plus B to the 5th. Now suppose instead of writing A here, we have 2x. And suppose we have a B here, we have a y cubed, actually a negative y cubed. So I'm going to call this the A position. This is the A position, and this is the B position. Now, since this is degree 5, the coefficients are still going to be the same ones that are in Pascal's triangle. Okay, so I can fill that in. Notice for each term here I have 3 parentheses, because each term will have a coefficient, an A position, and a B position. Coefficient, A position, B position. Coefficient, A position, B position. The coefficients in the front are from Pascal's triangle. This is the A position, A position, A position, A position, A position. And this right here is the B position, B position, B position, B position. Okay, so in doing these problems, you have to be really organized and just set it up. I would write a skeleton with the 3 parentheses for each term, fill in Pascal's triangle, numbers in the very beginning, put in your A position, put in your B position. However, there is one more thing I need to do to simplify this, okay? Now, notice on the outside here that we have exponents of 5, 4, 3, 2, and 1, and so forth. I haven't put those exponents on the outside here yet. So I need to go through and do that. So, remember, as the powers of A go down, 5, 4, 3, 2, 1, 0, the powers of the B position go up. 0, 1, 2, 3, 4, and 5. Okay? So this right here would be called the setup. Okay, I just have it set up, but it's not the simplification. So here is the tedious part, and you have to remember your order of operations. So if I'm going to simplify this right here, this piece right here, I not only have to apply the exponent of 5 to the x, but also the 2. 2 to the 5th power is 32, x to the 5th. Okay? Anything to the 0 power is 1, so that y piece just disappears. Plus 2 to the 4th power is 16, x to the 4th. Now this negative here, if there's a negative sign in the original problem, you have to include that. Let me highlight it in yellow here for you. Or how about orange? You have to, if there's a negative on the original problem, you have to put it, notice I put it inside the parentheses in the B position here, okay? So make sure you do that. So going back to this, this negative here is actually going to make this whole term negative here. Okay, so I got a minus sign and y cubed. So the exponent of 1, negative raised to an odd power is negative, so it's going to make this whole term negative. 16 times 5 is 80, 80. X to the 4th, y cubed. All right, now it's a little bit difficult for me to write in the small space, so I'm just going to simplify one more term for you right here, and because I think you got the idea. But you would do 5 times 2 is 10. That's my cat meowing in the background, to the first power. Now this term is going to stay positive because this exponent is even, all right? Y to the 12th power, because I'm raising a power to a power, you multiply, okay? Power to a power, you multiply. This last term here, this is an odd exponent. A negative raised to an odd exponent will make the whole term negative. Anything to the 0 power is 1, and this becomes y to the 15th. So, let's recap here. If you have a plus b to the 5th power, you just take the numbers in Pascal's triangle. You got your a's and your b's, a's and your b's. As the powers of a go down, the powers of b go up. Now, if the problem has, instead of an a, you have a 2x here, and instead of a b, you have a y cubed, you just put them in the parentheses where a and b went in the previous example, like I did here, okay? The coefficients stay the same, and you're just going to have some tedious simplification with laws of exponents, and for example, this 2 applies to the 2 and the x, so that would be 4x to the 2nd power, and then the 4 gets multiplied to the 10. And last thing here, if there is a negative in the middle, what's going to happen is that the terms are going to alternate between positive, negative, positive, negative, positive, negative, positive, and negative, okay? So, the purpose of this video was to show you that Pascal's triangle is a tool to expand binomials raised to any power, that the coefficients of the final answer will be found in the triangle. You do not have to work these things out by hand.